Hello friends, welcome back. In this session we'll have another 10 to 12 questions quickly and I hope you definitely like it. Mention the low bias ML algorithms and high bias ML algorithms that you are aware of. Decision trees, KNN, SVM are all classified as low bias ML algorithms, whereas linear regression and logistic regression can be quoted easily as high bias machine learning algorithms. Mention the types of biases that can occur during sampling. There are three types: selection bias, undercoverage bias, survivorship bias. These three are there. Define selection bias. Selection bias occurs only when the sample obtained is not a representative of the population intended to be analyzed. I mean, whatever you have is not sufficient for the task that you have chosen. An instance can be this, very simple. I'm going to select only the Asian COVID data to perform study of world COVID impact. You cannot really get a real good result because you have not taken the complete data that is required for the analysis. So this is called selection bias. Define undercoverage bias. Undercoverage bias occurs when some members of the population are inadequately represented in the sample. A survey is taken to understand the living standards. If you take the survey only with the low income people, it would definitely suffer. You need to consider the low income, medium income, high income people to understand what exactly is the living standards. If you take only the high income or the low income, it is going to definitely suffer and it is called as undercoverage bias. What is PCA? Can you give a quick note? PCA is nothing but principal component analysis and it is a statistical method used in machine learning. Its idea is simple and it's all about projecting data in a higher dimensional space into a lower dimensional space by maximizing the variance of each dimension. It is all about projecting the data in a higher dimensional space into a lower dimensional space by maximizing, I repeat, by maximizing the variance of each dimension. What is linear regression? Very simple question. You can answer this with ease. It is a simple technique used to find the relationship between the input and the output. That is the independent variable and the dependent variable. Input is always independent variable, output is always dependent variable. By doing this way, we can understand the relationship between the input and output, and I have presented you a very simple graph here in front of you for you to understand what exactly is this. You can see that I have got input variable here, output variable here. Input is independent, output is dependent, and the regression line is drawn. This will help us in understanding what exactly is the relationship between the input and output. Why do we need to go for linear regression? As I told you in the previous question itself, we need to get the clear understanding between the clear relationship between the input and output. We aim at the estimated value and the actual value. We need to understand the difference between the estimated value and the actual arrayed value, and regression line helps you in getting that clarity. So we can minimize errors once we understand what exactly is the deviation. That's exactly is the purpose. What is positive relationship and what is negative relationship in the regression plot? Very simple. If x-axis increases and simultaneously you see the y-axis getting increased, we call it positive. I work for 5 hours, my wage is $5. I work for 10 hours, my wage is $10. This is positive. Negative is simple. I watched a TV, I watched a game, or I went to shop. My exam is there, and the next day I scored less marks. So more the number of hours you spend on your extracurricular things, I mean more the time you spend on the TV or Facebook or whatever, less the marks would be. So more the time I spent on something else, less the marks would be, and this is called negative relationship. That's it. We've got two types of relationships. One is positive. If the independent variable increases, dependent variable also increase, it is positive. If the independent variable increases and dependent variable decreases, it is called negative. Mention the steps involved in the development of a linear regression model. Very simple. It's very consistent actually when you go to machine learning. I'll collect the data. I'll do the pre-processing, cleansing the data will happen. I'll make sure the data is sanitized. I will divide the data. We need to go with the training and validation split over there, and then the data exploration will happen. Finally, I will build the model and I'll do diagnosis and I'll go ahead with validation of the model. That's it. It's a very simple flow which you can follow. Define logistic regression. Where is it useful? Logistic regression is 100% mathematical model which will predict the probability of occurrence of y given See, let me make it this way. Logistic regression will tell you if y will occur or not. Logistic regression is always binary. It will tell you y can be either 0 or 1. Y gets 1 if the event occurs, y gets 0 if the event does not occur. It is mainly useful in the problems like the spam classification, the diabetes detection. All these are the simple. Email is the best example that I can refer you. The Gmail can classify this mail as a spam or useful mail using logistic regression. It's all binary there. So that's a simple example that I can quote immediately. Differentiate, classification, regression, and clustering. You can see that here regression is all about prediction. I predict 170 centimeters, 168 centimeters, 195 for these 4 people. Classification, I am classifying them as grown or growing. Clustering, I group them into a cluster. You will cluster them. This is cluster A, this is cluster B. That's all. This is a very important question, and most interviewers ask this question. With the same scenario of your choice, differentiate clustering and classification. We are taking the customer risk classification as a simple example, and when I classify, I can classify them with their age and salary inputs as low risk customers and high risk customers. You can see that here I am clustering them. I am clustering them as low risk and high risk. That's the difference. You can see that this is classification and this is clustering. So remember it, and this is a simple example that you can quote. Explain how KNN works. This is something which is very important, and 99% of the interviewers will ask you this question. KNN is based on supervised learning. It's a very simple approach based on the history, the current option, the current level is predicted. Based on what has happened, I will tell you what is going to happen. Very simple. When a new data is coming in for classification, based on the similarity of the data which is available in the past, the new one will get classified. I am bowling a ball. I already have a list of 5 or 6 deliveries that I have bowled. Now I'll classify this ball based on the history. You have bowled a Yorker, you have bowled a full toss, you have bowled a short pitch, what it is, and I will group it. The most similar category shall be found, and the new entry will be classified as that particular category. Very simple. The new data can be classified with ease because we have similar data which is already available in the history, and I will group it accordingly. And here you can see that I have given a very simple example here. Class A is red stars, class B is green triangles, and whenever there is a new entry, I'll see. Now this new entrant is having 1 red star and 2 green stars. So which is quite obvious. Naturally, the new entrant is classified as the green triangles. That's it. That's very simple. So history will help me in deciding what is right and what is wrong. I can classify easily through the historical references. That's it. We'll have more questions in the next session. I hope the series is useful. In case you have any questions, suggestions, please go ahead and type it in the comment section. I'll be happy to answering you. Thank you. And if you like the channel, please subscribe.